Hi, today I'm going to talk about how to make a robot that follows light. This robot's gonna be a robot that would stop when there's no light, but it will follow the light, basically. You put light on the robot, like put the light in front of the robot, and it would go towards the light. So this is the concept. And the parts we need to use are 12 by 12 Perfboard, but you can go like, it doesn't need to be perfectly 12 by 12, but around that size. 10 by 10 could work too, like 11 by 11, 12 by 13, 12 by 11, just around that range, so that you have enough space for the circuitry and the motors, but it's not long enough so that it wouldn't be able to steer with only 2 motors, because this project would run on only 2 motors when it comes to the robot's powertrain. So there's just a tiny little what is it called? I don't know what this is called in English, but it's just a small little plastic wheel that would just, you know, lift the motor up, lift the robot up from the ground, and yeah, it would be able to, like, you would be able to like use it with only 2 little motors. So the components we need, as I said, 12 by 12 Perfboard, 2 DC motors that have these wheels and gearboxes on them, they're pretty cheap, 2 LDRs, like so, 2 10K potentiometers, 2 BD138 transistors, BJT, and 2 BJT BC547 transistors, 2 LEDs for indicating which side of the robot is powered, and 2 resistors for these LEDs, which are 100 ohms each, and we need 50 ohms, 2 50 ohms resistors. But if you don't have 50 ohms resistors, you can just put 2 100 ohm resistors in parallel and get the same amount. And we also need 2 100 ohm resistors also for the LDRs. So this is basically the components list, and you also need to use a little bit of solder and some wires to make the connections on the back, as you can see. And you may need a little power connector for attaching a battery. But you don't need to have a power connector. You can just attach a AA battery holder that would hold 4 AA batteries, so it would like make 6 volts, and this robot can run on anywhere from 7 volts down to 4 volts. So you can just put a lithium-ion battery in here, or 4 of these AA cells, just the cell holder. But I'm going to do something else so that the robot would be a little bit faster, but not very slow. Like, I made a battery pack with an 18650 that you can attach to it, and this battery pack would boost the voltage of the 18650 no matter how charged or discharged it is. And it's also got a little TP4056 under this Velcro sheet, and it's basically for securing the cell, security of the cell, and like charging of the cell. And there is also an XL6009 voltage booster. I'm gonna also use this battery pack for other robots too, so I made this especially beefy with the XL6009, because if I only put like an MT3608 on here, which is 2 amps only, which is pretty weak for other robots, other powerful robots that I will be doing, so I just put the most powerful voltage booster that I can fit on an 18650 battery holder. You don't need to use a PCB type 18650 battery holder, but they are much more convenient for working on them, and they're just, to be honest, from my experience, a lot more like properly built, these PCB type 18650 battery holders, because the other ones that have the little spring on them are kind of crappy, and once you put the battery in there, which takes a lot of force to put in, you really can't take it out. But let me just show it and show an example here. You just click the battery in like this, and then you can just grab it from the sides and just pull it out. It's that easy. But on those springed ones, it would just squish the battery so hard to the point you can't even grab it on the sides and pull it out. You actually need to use a screwdriver to pull out the battery from those battery holders. I don't know if I got a bad one or all of them are like that, but yeah, my experience weren't all that good with those types of battery holders, and like using a screwdriver to pull out a battery is also very dodgy to do, and this is a lot safer basically. And if you want to basically without using solder or taps on the battery, without doing any modification on the battery, if you just want to put it there, it just holds it pretty nice and snug. You can just it's not going anywhere. But if this robot's going to be like very, very powerful, and you put an even bigger voltage regulator on there, and your battery is beefier than what I have, which this battery only, I think, can supply up to like 6 amps, 7 amps, I think. And this is just a Power Extra 2500 milliamp hour battery, and I've like stored this in storage mode for 2 years, 2 whole years, without even a cycle from like since I bought it. And the CID didn't trip, the battery didn't overheat when I tried to use it again. After a couple of cycles, it had a little bit of heating up issue, but after a couple of cycles, that just went away. Like it wouldn't get too hot while charging that it would burn your fingers or anything, but it would get noticeably warm. And lithium-ion batteries shouldn't exceed 36 degrees while charging at especially higher currents, like more than 1 amp. And if they exceed that, they can lose some capacity over time. And it was definitely exceeding above 36 degrees, but it was just warm. It wasn't anything critical. And after a couple cycles, as I said, just 2 or 3 cycles of draining the battery and filling it up again, that just went away. So Power Extra, really, really good brand. I never really heard of it. Like, I thought it was like a knockoff brand or anything, but no, it's a legit battery. And the capacity actually came out as 2400 milliamp hours after like 2 years of doing nothing with the battery, and that's like within spec, like within an error margin. So really, really good batteries by Power Extra. I really recommend them if you can get them. But yeah, you can also get other reliable brands like Sanyo, Philips, not Philips, Panasonic, Samsung, Sony, and other brands, other battery brands that are well known for manufacturing batteries, like LG, some good brands like that. So this battery pack, as I said, boosts the voltage from 3.7 volts, nominal voltage for an 18650, and boosts it up to 5 volts for this robot, which is not too low but not too high, so the motor's lifespan is going to be a lot longer, and the transistors aren't going to be all that much stressed under load. So the higher you go with the voltage, I don't recommend going over 7 volts with this circuit. I'm gonna have the circuit diagram in the description, but if you go over 7 volts, you may need to attach little heat sinks to these transistors because they get hot even at like 7 volts with the motors on the ground and kind of being on load. So let's demonstrate how it works for a second. I may need to close some lights on the room because you need to tune the sensitivity of the LDRs or the sensors from these potentiometers, 10K potentiometers, and once you like really turn them up so that you have really good in-spec light detection on a very like bright space, this robot really works very well on like nighttime and very lightly lit rooms. So I'm just gonna turn down some lights in this room to make it work better. I usually turn on all the lights for making the video look better, and I just use Velcros to attach this battery pack on top of the motor, on top of the robot, as you can see. So I'm just gonna attach it like this, and as you can see, that battery pack isn't gonna go anywhere. And as I don't know if I mentioned it, but there's a small little switch that powers the XL6009. Even though these voltage boosters are not under load, they still draw some current from your battery when they're wired up. So just to not drain the battery completely, if I left it on the battery holder, I just added a switch so that you don't drain it you don't drain it too much. Even though you can't even do that, because there's a protection circuit with the TP4056 on there, and you can watch the video I made about the TP4056 and its specifications and its, protection circuit. But yeah, that's about that. So I used just 2 JST connectors here to connect the power up, and I also used the same JST connectors on my other robots so that I can connect this battery pack to any robot that I have or any electronic project that I have, because these connectors are really cheap and they can deliver up to like 5 amps, which is really good for high power circuits. And yeah, let's power it on. So I'm just going to calibrate this through the potentiometer, and this potentiometer is a little bit old, so it has like a little bit of corrosion on the tracks of the potentiometer. As you can see, when I just wiggle it a bit, it like triggers for no reason. So just gonna find the spot where it doesn't trigger anymore, and these LEDs are gonna be really useful for calibration, because the LED, as you can see, turns on way before the motor turns. Like if I hold it like this, the LED is lighting up but no action is happening. So just gonna set it up right before the LED lights up, and as you can see, when I bring my light close, it just lights up the LED. So it basically works like this. Why did it do that? Anyway, let's test it out on the desk a little bit. It's going to be very limited, and this desk is quite small for the robot. I hit the keyboard. So the best thing that I could probably do for this robot is to take it on the ground and test it there, because this table is just way too small and not suitable for this robot. So we're here on the ground and we're gonna test the robot. And from my TP4056 video, I made this flashlight and talked about it, like how this works. You can go watch the flashlights video and the TP4056 video, which is just joined together into one video. But let's start out and test our robot. Why do I need to sneeze while I'm filming? As you can see, it struggles a little bit on the carpet because this teeny tiny little plastic thing there isn't helping much. I'm gonna replace that with a bigger one so that it can also go on the carpets, but on the carpets this robot just wouldn't go. So as you can see, it's going to the light pretty nice, doing left and right. You can't really see because I also need to hold the flashlight and the camera at the same time. Stop it. So As you can see, come on. As you can see, the robot's tracking the light pretty well, even from a far distance, because I'm just standing up and holding the flashlight like this. As you can see, I can detect it even right now. It's pretty good. And the LDRs aren't looking up right now, so let me just change that. What I mean by LDRs are the light sensors. That's much better. It just hits the carpet. Anyway, you get the point. I could have demonstrated this in a larger area, but I couldn't for now. It's just this small little corner in my room that I tested in, and yeah, works pretty good so far. And this is basically it for this video. If you liked my videos, please subscribe, and please don't forget to like my videos. And if you share my videos to your other friends, it would really help out my channel. So thanks for watching, and see you on the next robot video.